So with the continuous increase of AI in the software development process and the ever-growing volume of builds that are run in CI, these four horsemen appear more and more often in your CI environment, killing developer productivity and feature delivery. Slow pipelines, unreliable pipelines, failure overwhelm, and shallow observability. I've definitely seen them in our own builds. I've seen them with many customers, and I assume you have seen them as well. Right? But there is hope. Right? Through the introduction of a universal cache, we can get back to CI efficiency. Right? Faster builds, reliable builds, efficient troubleshooting, and deeper observability. My name is Etienne. I'm the SVP of Engineering of Gradle and Develocity co-founder. And with me today is Mirco, who's a senior engineering manager on the Develocity engineering team. So the state of CI at many companies, from what we observe, is getting increasingly inefficient and increasingly expensive due to the sheer volume of builds and pipelines that you need to run. Right? I assume there's nobody in the room here who says, well, we have less and less builds running in CI. Let's look at this a bit into more detail. What is happening, right? So there's a volume, there's an explosion of build volume, right? And with AI, as was also touched upon yesterday by Hans in his keynotes, there is an explosion of builds that need to be run due to more code being written, more tests being written and generated, that all must be built, they must be executed, and they must be deployed. And this increased volume of builds, as well as build sizes, individual build sizes, puts tremendous pressure on CI. Now it gets even worse due to the inevitable introduction of errors that come with AI, right, at a certain rate. That was also touched upon yesterday. That comes in code as well as in tests. The pressure on CI increases even more because you have to build even more, right? Everything that introduces a failure, you need to rebuild. Flakiness needs to be rebuilt, and even worse, you need to investigate it. Right. That whole problem of building more is exacerbated by the continuously increasing use of ephemeral builds, right? Where you basically start on a blank sheet every time you build, which leads to a lot of repetition, right? A lot of things are re-downloaded, dependencies, JDKs, wrappers. Also things are calculated that need to go into the build over and over again. And also the work that is done during the build is executed over and over again. Now, it's not only CI itself that is impacted, but also the systems that your CI depends upon. For example, a dependency repository. So the more you build, the more strain you also put on these external systems like a dependency repository. Now you could go ahead and implement and maintain dedicated solutions for each of these systems, but that is quite expensive and time-consuming. And it's also not where you want to spend your time. Right? And there is really a vicious feedback loop going on, right? Which is the more you build, the lower your quality of service will be, because you put more and more pressure on your CI. And the lower the quality of service, the more you need to build. Because as you build, things will go wrong because the quality of service is wrong. Things are slow, right? Things are flaky, unpredictable. So you need to rerun things, which then puts even more strain on your services and your CI. And then there's also the cost factor, right? In the past, when the quality of service was low, because build volume went up, people would just scale out, right? But it got to the point where this is just not bearable anymore from a cost perspective, at least for most companies, right? So other solutions need to be found to deal with that situation. Additionally, if your CI depends on systems that have a consumption-based pricing model, the more you build, the more you will also have to pay for the services that you consume, right? Which adds additional costs. I'd like to give you one concrete example that touches on several of the things I just mentioned. right? I would assume that most of you agree or have experienced this, that dependencies are a major source of CI inefficiencies. And there's a post from Sonatype where they stated that about 83% of the total bandwidth on Maven Central is consumed by 1% of the IP addresses, which can be traced back to a lot of large companies. Right? And so the question then comes up, how do you know if you're one of those 1%? How would you determine this today? Right? And if you could even figure this out, how would you know which projects, which pipelines, which builds are the ones accessing Maven Central at this high rate? And even if you found that out, what would you then do about it? So we believe we can turn this ship around. And we believe we can do this with caching to chase off these 4 horsemen and bring back the superheroes. Fast builds, reliable builds, efficient troubleshooting, and deep observability. It sounds simple, caching, but it's not trivial. Right? It definitely isn't. You need to think about cache key generation, cache entry eviction, distributed caching, how to size your caches, just to name a few things. Right? I'm sure you have seen derivatives of this quote, but I also wanted to add my own quote here. Right? So what do we get from caching? Right? Why do we believe that this will alleviate the problem? If you look at CI, there's a lot of redundancy happening. If you look across your builds, your pipelines, across all the projects, there's so much work done over and over again that is exactly the same work. Right? And with caching, you can remove that redundancy. And instead of redoing the work, meaning recalculating things, which can be expensive, regenerating things, and re-downloading any type of artifact, whether it's a JDK or a dependency, all that can be reused through caching, which then ultimately relieves the pressure on those systems. We get a nice positive side effect of caching or through caching, which is it will also improve the stability of our pipelines and of our builds, because we're going to rely less often on doing the calculations, which could be flaky, of generating things, which can be flaky, or accessing other systems, which can be unreliable, right? Because most of the time, once we have done the work and cached it, we can just reuse the result from the cache. That does not solve the root problem, right? But it helps with the current situation and relieving the pressure on CI. Many projects, from what we see with our customers at least, they already apply some sort of caching during the build, which means as your build executes, Gradle build, where it's tasks, Maven build, where it's goals, or an SPT build, those units of work do the work once, and then it can be reused in later builds if the inputs are exactly the same to that task or goal. But we can do more, we can do better. We can also cache things that are inputs to the build. Those inputs can be, for example, a JDK that is required for compilation, Gradle wrapper files that are needed to even run the Gradle build, right? Or dependencies. Many builds use many dependencies. They are basically inputs to the build, and they can already be taken from a cache and prepared before the build starts, so they are available when you run the build. Right? So in addition to doing things during the build, we can also do things, reusing things from a cache before the build even starts. And that's where we're going right now. CI is inherently distributed, and so having a caching solution that is also working distributedly is very effective. Understanding the effectiveness of the caching and the potential where you could save even more through caching, where you're not yet benefiting from it, is an essential part of caching itself, right? So observability is really a first-class citizen of caching. Because if you don't have the insights, how can you know how well it works? And how can you investigate, troubleshoot, and make informed decisions what to keep, what to change. So to summarize all this, a universal cache, the way we see it, is a distributed, highly available, high throughput cache that can store both build inputs as well as build outputs. And it does so with observability built in as a first-class citizen. Those build cache nodes that are part of the universal cache can be geolocated very close to where the actual builds are running, meaning you have low latency and less risks for any network flakiness. And they're lightweight and they're simple to deploy, and they scale well, and they're cost effective. Right. So with that generic description of how we see universal cache, Mirco, can you show us how we in Develocity provide such a universal cache?
Thank you, Etienne. All right. If you're familiar with Develocity, you know it collects a tremendous amount of build data. For every build execution, a build scan is published. A build scan is a record of a build. It contains key information such as failures, tests, dependencies, and more. And then we have the reporting and visualization tool, which enables efficiently analysis of aggregated data, aggregated build data to explore trends and identify bottlenecks. So let's think back on the question that Etienne asked before. So how do you know what is your degree of reliance on Maven Central, or for that matter, on any other external repository? Think about, as Etienne mentioned, consumption-based pricing, right? So it doesn't matter whether it's Maven Central or something else. You just want to know how much are you downloading from those repositories. So it turns out that thanks to Develocity, that becomes really trivial to answer. So let's see how. First, if we look in a build scan, in the dependency view of the build scan, we can navigate the full graph of dependencies and appreciate its depth. We can see exactly what version was resolved. And on top of that, of course, we can also understand the repository from which it was downloaded. Then within the same build scan, if we move to the network activity, we actually have a breakdown of all the dependencies that have been downloaded for the build execution that this build scan is capturing. So in the specific case, we see that there's been over 2,000 dependencies downloaded, and that amounts for about 1 gigabyte of traffic. And the other really, really interesting data point that we see here is that over 4 minutes was spent downloading dependencies. This is wall clock time, right? This is idle time for your CI. So it's a cost, right? Then the question that you may be asking yourself when you see such a build scan is, well, was that an isolated case? Or is there actually a bigger problem, right? And how do we answer that? We look at the reporting. We leverage the reporting and visualization tool for that purpose. So here we are looking at the dependency insights dashboard that is available and packaged and bundled within the reporting and visualization tool. So what we're looking at is a dashboard for the open source Apache project, so the Apache organization. And we're looking at the dependency that have been downloaded over a week of time for CI builds. Those are the filters that have been set. So we see that we have 29 repos or projects that are actually publishing build data. And we see that there are about 17,000 unique dependencies or unique version dependencies, right? Let's go deeper, right? Okay, 29 projects, 17,000 unique dependencies, but how much are we downloading them, right? So we see actually the total downloads is almost 30 millions. 30 millions time we're downloading different dependencies, but that's what we're getting from our repository. And the total size amounts of these downloads amounts to almost 7 terabytes. And the one data point that should really capture your interest is that overall, you're wasting 5 days, over 5 days, downloading dependencies. That's huge. So we still need to answer Okay, but from where are we downloading those dependencies? So let's just continue. And we can get the answer very quickly. We can just see what is the breakdown of where are those dependencies coming from. And we actually see they're all coming from external repositories. Maven Central is actually at the top. It's the first hit, and actually there is a second one down there because they have 2 URLs. So it's immediately clear that we have a high reliance on Maven Central. But it doesn't matter, as I said, whether it's Maven Central or maybe it's a different repository. You just know that you have such a reliance, and then that can impact the stability of your CI pipeline, right? At best, maybe your build is low. At worst, well, the services may be down, and then you have failures, which can have negative impacts across the whole organization. But we have a solution for that, right? Etienne told us about before. That is caching. And today, I'm very excited to announce that we are launching a new product, Develocity Artifact Cache, exactly to solve this problem with dependencies and more. But let me walk you through an example. So here we have another build scan. It's capturing, I would say, a typical execution that you could have on an ephemeral CI, right? And what is important to notice is that we have over 8,000 dependencies being downloaded. It amounts for almost 2 gigabytes of traffic. And the wall clock time for dependencies downloads is almost 45 minutes. And if you compare that with the overall build time, which is of about 50 minutes, you see dependency download time completely dominates this execution. So what we can do, well, we can deploy Artifact Cache and exactly repeat this experiment, right? And let's see the results. So in this case, we went from about 45 minutes dependencies download to just 2 minutes. That is over 20 times faster, right? And the overall build time was reduced from almost 50 minutes to just about 5 minutes. That is a major bottleneck that it's addressed right there. And by doing that, just think about, all that work that you didn't do, that now it's your CI and delivery pipeline, it's readily available to do new work, right? And this is how you can achieve higher throughput in your delivery pipeline. So some of you may have noticed or may wonder, okay, I was like, we are downloading a lot less, but why do we still have that 27 number up there? Does anybody have a guess? It's a tricky one, so I can understand that it may not come up. So that number is there because we actually have snapshots that are being downloaded as part of this build. And of course, we cannot be caching a snapshot because we don't know whether we have the latest one or not, so we're going to have to make the request, right? But that's okay. Artifact Cache is smart. It can understand that. And it will only be caching what is guaranteed to be stable and not changing, while anything that you still might have to go and fetch from a repository, well, it will still do it. All right, so we talked about dependencies and how Artifact Cache can help with that. But that's not it. Artifact Cache can do more than that. And there are other build inputs that it supports. So things like toolchains. So think about JDKs, right? Or Gradle configuration cache artifacts. All of those are, in the end, ends up being inputs to your build execution. And if we can just avoid doing that work, well, we're going to be faster, right, in our overall execution. So the actual architecture, it's pretty simple. We just have a client and a server. So on the client side, it's a CLI application. You essentially just instrument your CI job to say, before actually executing the build, fetch all the build inputs that you need through the artifact cache, execute the build, and then you call again the CLI to upload the difference essentially between the beginning and the end, so that the cache is always up to date, right? And on the server side, we just have a service running on the Develocity edge that provides distributed and low latency and build caching service. So we covered build inputs, right? But what about everything else that happens during the execution of a build, the build outputs that are produced by the build? Well, for that, we have the build cache, right? So let's see an example of how much of an impact the build cache has on an organization. And again, we can just look at the reporting and visualization tool. This is for the Spring organization. And again, we're looking over just a span of 7 days, right? And only focusing on CI builds. And the number that I want to attract your attention on is the total build cache wall clock savings. So it's in the top right corner. So over 7 days, we've been saving almost 27 days of work, right? That is a full-time engineer that, and actually more, because we don't get the luxury of only doing our work and only working on building the product. So you also have to account for meetings and other things. That is huge, and it's over 7 days. That's what you get back. So the Velocity Universal Cache, it's a unified layer, caching layer that is highly available and geolocated. And it serves your entire organization. It sits next to your infrastructure and developers so that you reduce latency and network traffic, and you just accelerate your delivery pipelines as much as you can. So that's a lot of text. A picture is worth 1,000 words. So let's actually have a look at a diagram here. So here we have 2 availability zones. This is just representative of how you could deploy the universal cache in your own infrastructure. You have 2 availability zones. In each of them, you have CA agents running, your servers running, your delivery pipeline, essentially. And then you deploy the Velocity Edge next to them, right? As close as possible, because this is what is going to enable you to really get the most benefits out of it. So the Edge is going to run the build cache and the artifact cache side by side. Your CI are going to be interacting, right, with the Edge and just getting whatever build outputs or build inputs is required in order to complete a build execution. And then across the different availability zones, you will deploy different edges, instances. Each edge can contain multiple nodes that you can scale depending on the needs that you have. And you have a layer of replication so that in case of a disaster, essentially your other availability zone just takes over, and it's completely transparent for everybody. Yes, it might become a bit slower maybe for your developer working maybe remotely, but from a CI perspective, it will continue to be as efficient as possible. So Etienne, how about you tell us what are the key takeaways from this session?
Yep, will do. Thank you, Mirco. All right, so with that, we'll wrap up. Basically summarize what we tried to show you. So using a universal cache, or specifically the Develocity Universal Cache, we can accelerate builds and make them more reliable by caching build inputs as well as build outputs. Build inputs could be dependencies, major contributor, could also be JDKs, Gradle versions, Maven versions, and so on. And we can do so across multiple build systems. Right? It's one build cache that can serve multiple build systems. We can surface deep insights about what happens related to caching. We can also surface many other things, and we do. But we do surface caching-related insights that help you first understand what is the potential of caching if you applied it, right? That might help you if you need to make a case to your boss because you want to try it out. And you can tell him, look, this is the predicted savings if we apply this technology. And you can also use these insights to see with hard data, how much are you actually saving? And beyond that, the insights will also tell you what is the reliability of your builds using the cache as well as not using the cache. Right. It reduces the pressure on your CI and avoids that you need to scale your infrastructure, your CI infrastructure, as well as your external systems used by CI, right? Which can be very costly, as I touched upon earlier. Also, or especially when you're using consumption-based pricing model services. It's a single caching layer, meaning it's very easy to integrate, and it means you don't have to worry about having a caching solution or another mitigation solution for each system you're using. Right? Maybe because you could say, well, I have a system to download JDKs. Well, we need a solution for that. We're downloading dependencies from somewhere else. We need a solution for that as well. Using a universal caching layer, it's all taken care of. And you can deploy it to any CI systems. Right? It's at this point CI agnostic or CI provider agnostic, so it will work with all of them. Having CI plugins to additionally facilitate the integration will come. Right? And very important, it does not require making any changes to your projects or builds. Right? So if you're on an infrastructure team, on a central team, and you would like to make developers happy again by giving them fast, reliable pipelines, you don't need to go to them first and ask or convince them, well, you know, if we did this, you would benefit from it. But instead, this is a purely server-side change. And it doesn't change the behavior of your software or of your build, right? It just adds this caching, but the behavior itself stays the same. So that really reduces the friction or the hurdles to roll this out organization-wide. If you would like to talk more about it, learn more about it, or have questions, you can visit us at the Gradle booth. We have one over there. We will be there. Or if you're interested in becoming an early adopter, because it's ready for use. We use it internally as well already, and we see great results. Come to the booth, and we can work that out. All right. With that, thank you very much, and have a good rest of the conference.